All right, what's going on, guys? So today's video is not going to be that long because we're just going to go over some of the weather fronts from the notes that I posted on Friday. Okay. Um. So really quick, just a little bit review. When we're talking about weather fronts, okay, especially when we're talking about wind and pressures and all that, make sure that we always remember that it's always going from high to low. Okay. So this is my little review thing. And a high pressure system, it's always going outward and it's always going in a clockwise rotation. I always remember the clock is high on the wall and clocks always go clockwise, okay? Now low pressure system, this is inward, okay? All the wind is going in towards the low pressure system and it's counterclockwise. That's why all of our hurricanes all have a counterclockwise pattern going around. Especially when you get an aerial coverage of a hurricane, you'll see that it actually spins when you guys look at those videos and photos. All right. So also with a high pressure system, usually there's not much weather, so high and dry, because it's pushing all the clouds out. Remember, you need clouds to really have any type of precipitation. Now, low pressure systems, since everything is getting brought into it, that's where all those clouds are going to be forming. All right. So that's where you get your storms. So low and lousy, high and dry. Okay. So really quick, since we're doing fronts today, all right, and I just wanted to go over some of these definitions and these symbols. A front is a line that separates air masses. So we have gone over a couple of the air masses. It could be polar air mass, which is usually cold. It could be a tropic air mass, which is warm. All right. And how they interact. So you'll see that on the side over here, I have a cold, warm, stationary, and occluded. Those are the four types of front that get brought up with the air masses, okay? So fronts, there's only four of them. So you have a cold front. So that's going to be cold temperatures. Now, notice the symbol. You don't have to have the symbols memorized because if you go into your reference table, it's actually at the bottom of page 13, okay? It says where the air masses are, and then it also says what the fronts look like. Now, the reason why I use blue is if you ever watch the weather, most weather channels, they actually mark cold fronts blue and warm fronts with red, all right? And the symbols are a little bit different. So if you notice with a cold front, it looks like triangles sticking up, okay? So I remember it this way. The triangles sticking up, those are like icicles. Cold front, it's cold. Those look like icicles. Now, the way to figure out which way it's going is whatever way the arrows or the triangles are pointing, that's the way that's going. So this cold front is actually going up on my board, okay? So if this is on a map, and we know that north is usually always at the top unless they tell you otherwise, that cold front is heading north, all right? Now, a warm front is always in red. So I always think, a stove usually turns red when it gets warm. That's your warm front, and it's half circles. So I always think of the sun, okay? So again, these half circles, whichever way they're facing, that's the way that the front is going. So in this case, it is also going north, okay? Again, those are just my symbols though. When we start looking at maps, we'll start to figure out which way they're going by the direction that these are pointing, okay? And like a cold front, a warm front, everything behind it is all warm temperature. Everything behind these symbols for the cold front, it's all cooler, colder temperatures. Now you get into a stationary front. So in the case with both of these, they're both traveling the same direction, okay? So they never come in contact, but sometimes fronts come in the same contact. So let's say that we have a front going east and another front going west. So they're going to crash into each other. And what happens with that is it's called a stationary front, meaning it's not going anywhere. Think of a stationary bike. You can go on a stationary bike, but that stationary bike at the gym, it never moves, okay? And that's what's happening with these fronts. So if you look closely, you'll notice that my cold front symbols are going up this way. So the cold front is actually going north, all right? But my warm front symbols are actually going south, okay? And because they do this, they're not moving at all. They're just staying there, okay? So that's called a stationary front. Now, the last one is called an occluded front. So we kind of see it almost happening up top with these two. An occluded front is, let's say we have a cold front going north, okay? Just traveling, all right? This is the cold front. But now, let's say directly behind it, you have a warm front catching up to it. Okay? So it finally catches up to it. And now you have those triangles for the cold front and the half circles for the warm front. Okay? It means that the warm front caught up to it. And now they're moving as one. They're occluded. Okay? They both occluded each other. Okay? So those are the symbols. If you ever see a map and you have to ask what is going on behind it, okay? And this is when our station models come in. So when we're doing this and you see a map and then you have a station model that's behind it, okay? So notice how I have my giant station model for the cold front. Then let's say I put the line coming out. It means that the air mass is coming south and it's moving that way. And since it's behind a cold front, it's probably going to be cold. So we could put this at, 40 degrees Celsius. Whereas if it was behind a warm front, we would probably put the same station model, okay? You have the line going this way. So that means, we make a little arrow. And since the warm front, we probably maybe put something a little bit higher in temperature, 75 degrees Celsius, okay? So when we start looking at maps, I'm going to post that PowerPoint slide after this, you'll start to see that where those warm front and cold fronts are, behind them, it's warmer or colder temperatures. All right. So that's just talking about our four fronts. Now what we're going to get into is what happens when a cold front and a warm front hit each other. Yes, they make a stationary, but there's other things that happen during that time. Okay. So I'm going to get rid of this. We'll keep these. All right. So for the first one, we're going to talk about a warm front. Okay. So a warm front is this guy right here. Okay. We have a warm front hanging out over here, and we have a cold front over here. So what happens is, let's say this cold front's not moving, just hanging out, just cold air. The warm air comes in, and it hits the warm front, or I'm sorry, the cold air. Now what happens with warm air? Does it rise or does it sink? It rises. Warm air rises. So what happens is it hits the cold air and it needs to go somewhere. So it's going to start to rise up and it keeps going. And it makes this almost like this ramp, this slant, where the cold air goes underneath it now. Okay? So as the warm air rises up, it starts to cool and condense, and this is what makes those clouds. So over this giant area, you start to get clouds, you start to get precipitation, and for the most part, it's a light rain, okay? So this light rain is in front of the boundary. Now, what I mean by boundary is, here is my warm front. If we made a box around it, this is where it's starting. This is the front of it. Okay? Because the warm air goes up, now the precipitation is happening in the front. All right? So warm front comes in, hits the cold air, it starts to move up. It's got to go somewhere. So it basically goes on top of it. And because it goes on top of it, it starts to get colder up at top, makes those clouds, and now you have the light rain. Now we're going to talk about the cold front. Okay, so the cold front's a little different. Now I have my box, and now I have my warm air over here. So remember, my cold air wants to go this way. My warm air is just hanging out. The cold air hits, and because it hits it, it's going to cause the warm air to go up really fast, okay? Because this is the one that's hitting it. So the warm air goes up, and it actually forms the cloud right here, and it's a lot more. So this is where you get your heavier rain, your thunderstorms, okay? Your big precipitation movements. And the difference between the cold front coming in and a warm front coming in is a cold front, okay? Remember how we talked about with the warm front where the precipitation happens in front of it? A cold front, it happens right at the boundary. Because when it smashes into that warm air mass, it's going to create the cloud right here. It's going to be a bigger cloud. So it happens at the boundary, all right? And that's what we go from here, okay? So that's all. Again, it was very short, but I just wanted to go over this stuff. And then I'm going to be putting up a video that kind of demonstrates what I was just talking about, all right? If you haven't looked at the slides yet, make sure you're looking at the slides, okay? Again, if you guys have any questions, definitely message me, okay? Hit me with reminds, an email. I know you guys are working on the Google Classroom. Do not worry if you're handing in anything late, okay? I'm just happy that you guys are doing it. It's not the best circumstances, how you guys are doing this. I can only imagine. But, you know, you guys are doing great, all right? So keep up the good work. Again, if you have any questions, let me know. And hopefully I see you guys soon, okay? All right, stay safe. I'll see you guys later.